Let me say a couple of things about time. Time is something we in eye care don't pay as much attention to as I think we should. There are two aspects to time that I think we need to pay a lot more attention to. The first aspect of time is diagnostically. And what I mean by that is when I'm looking for intermittent central suppression, ICS, when I'm looking for that, I'm trying to find out how sensation gets from the eye up to the brain in one piece consistently over time. And so I will sit and watch and listen as kids or adults are watching a target where I've got the two eyes separated, and so one eye seeing over here, one eye seeing over here, and the question is, do both eyes get both images up to the brain simultaneously? There's nothing about the target that makes it so one eye should interfere with the other. So over time, over a period of 20, 30 seconds, over a number of different subtests, so that I don't just have a kid looking at the same target for 10 minutes saying and beating him up with questions about, are you sure, are you sure? No, the idea is as we look at how eyes respond and how this person responds over time, do we have consistency in the image getting from, again, from the eye up to the brain? And that is not not common in healthcare to take time looking at those kinds of things. In fact, in a lot of ways, it's antithetical to how we in eye care are instructed to do things. So what often happens with looking for ICS or looking for suppression in general, a doctor or somebody working for the doctor will throw a depth perception test in front of somebody, and you go through the depth perception test and pick out what sticks out toward you or something like that. And so if you get to number 9, if it's 9 subtests, and if you get to number 9 and you get it right, you must be okay. Well, in fact, I have a similar test that I project on the distance chart, and so it's roughly 20 feet away, and there are just 4 lines that have circles that stick out toward you. If you have that specific form of depth perception, it's called stereopsis. And so one of the things I ask commonly now is when somebody can get all four lines of circles right, they can pick out which circle sticks out. I'll say, okay, now look at that bottom row. You think it's this circle that sticks out, is that correct? And they'll say, yep, that's the one that looks like it sticks out. Okay, does it always stick out? And fairly commonly, with the kids especially, whose eyes don't work together, who have ICS, they'll say, no, it flattens back down. Well, what's happened there? Well, when the central vision of both eyes combines fairly well, then you get that depth perception, and the circle sticks out, and they can see it. Then, if the central vision from one eye drops out, as happens in ICS, it flattens back down again. And so, again, over time, things change, and that's how we determine. That's how I determine how the eyes are working together. And one justification for that is if your child sits down to read, does he read for 12 seconds at a time? Well, maybe not. Maybe he has to read for several minutes. So we should determine how eyes work over time, and then we can figure out if there is some interference in with vision that's causing a problem with things like reading. Reading is one of the big things that people complain about. As I say, parents complain about. Kids don't have problems. Parents have a lot of problems, but kids don't have problems. But in my research, the hierarchy of things that people complain about, reading is number one, spelling and handwriting is second, third is math, but it's usually when you get to story problems or lining up a column of numbers. And then fourth is sports problems, that flattening of the depth perception I was talking about. Imagine that when you're tracking a fly ball. So one of the things I'll say to parents is, as a group, it's very difficult to pick individual behaviors based on suppression. But as a group, this is a group that's a little more likely to catch a fly ball with their face because of the flattening of the depth perception. There's one other thing about time in treatment. One of the things we will use in treatment is rapid alternation between the eyes using liquid crystals. And if you want to see some of the research we did on that with amblyopia with the lazy eye, you can Google Eyetronics, Eyetronics. And Eyetronics funded an amblyopia trial, and there's some videos on that where you can see how rapid alternation works. But basically, with rapid alternation, again, the fundamental defect is in motion detection. On-off flicker is motion in stimulus form. So you can imagine if I'm looking here, and then imagine a really skinny bar of light going by like this. Well, as far as the cells in my eye, they're looking out all over the place trying to watch things. As far as those cells go, that's on, off, on, off, on, off, on, off as that bar of light goes by. So on, off, and motion are on a neurological level are essentially the same thing. And if we are alternating between the eyes at the right pace, we alternate at the pace that the neurology is tuned to pick up. And with a direct alternation, there's enough carryover as things are going on and off. There's enough carryover from one eye to the other that the brain says, I'm seeing with both eyes simultaneously. And it's the same process as why you see a movie, why you see motion in a movie. A movie is a bunch of still photos. You fly them by fast enough and it looks like motion. Same process. So if we can find the pace that the central vision is tuned to pick up on-off, that's usually about 5 cycles a second. And then if we alternate directly between the eyes, we can literally drive the visual neurology to work. We can build connections at that relay station I keep talking about, the LGN, and build the connections and strengthen the connections in motion detection. And as we do that, we can reduce the ICS, reduce the suppression.